for having me. I am Suvodeep Mazumdar. You can call me Deep, and I'm a lecturer in the University of Sheffield in the Information School. Now, there is a talk that I will be presenting, but what I've done is I've pre-recorded this talk, so hopefully it will go very smoothly and we will not have network issues. So let's get on with the pre-recorded session, and then I'm happy to take more questions afterwards. So IDP, are you okay to play the video?
Hi, Dr. Suvodeep. Yep, we'll get right on that. Just give me a second. Yep. Thanks.
Perfect.
This online session about trends in data science for decision making. I'm going to be talking a bit about data science in general, and then I'm going to be talking about what we feel might be coming in data science over the next few years. Now, bear in mind that this is a very broad subject, and it has evolved quite a lot and continue to be evolving. So what I will be discussing might not come true, but hopefully this is where we are seeing data science to progress towards. So a bit about me. I am a lecturer in data analytics at the Information School, and I'm in the University of Sheffield. And my teaching is on data visualization, big data analytics, and I teach several subjects as well. My research is on human-computer interaction and data visualization, big data, citizen science and crowdsourcing, and I apply a lot of these techniques within different domains such as aerospace engineering, smart cities, urban planning, emergency response, and so on. If you're interested about more of my research, you can go to the link below and you can read about my papers and so on. So let's get into the topic. So why is this important? Well, firstly, it's important for us to understand that our world is increasingly digitized. What that means is that everything that we observe, everything that we write about, talk about, is being recorded, is being stored and digitized, and hence is available to us. We capture data about our environments, we observe them through CCTV cameras, we observe them through satellite imagery and so on. We also capture our data around our environments and weather sensors, temperature, and so on. We also interact with environments, we interact with objects, and in doing so, we record that. We have a nice coffee at a cafe, and then we record that, we upload it to social media, we talk about how we feel, and all of this information is digitized. At the same time, we also digitize legacy data, which means we have data on physical files, on physical documents, and we digitize them and we upload them and we store them. So all of this data that we capture, store, record, and so on is stored on hard drives, on devices, and eventually a lot of them are uploaded to cloud, more and more uploaded to cloud. So that means we are increasing our opportunities for digital data. At the same time, we have reduced costs for storage, and this is where the opportunity comes from. And now, big data is an area which has been generating a lot of impact over the last several years. In fact, this is a graph that was created sometime around 2015, 2016. And at that point of time, we were somewhere over here. And this shows the trajectory of the volume of data that can be generated. It's kind of like an expectation of what we would see around the year 2020. So at that point of time, we were somewhere over here, and it was kind of predicted that we would be generating a lot of data over the next few years. Currently now, we are beyond 2020, and this is what we have seen. We have seen enormous growth in things like social media, VoIP, enterprise data, and sensors and devices. One of the aspects of big data is that we generate more data than we can process. So think of the amount of data that's generated and think of what limitations we have in processing that data. Big data is challenging as well. We use typically big data for supporting decision-making tasks, So you can imagine big data being something like this, where it's very unstructured, lots of different data sets coming together. We perform some kind of analysis on the data. We have analytic solutions. We do something like processing that data, and that helps us in making decisions. And there we have more clear view of what's happening around us. So we've seen these challenges around big data, and over the last decade, or maybe a bit more, we have developed lots of different tools for using big data, for processing data, analysis of data, and prediction. We have tools in data mining, data visualization, big data analytics, natural language processing, AI, machine learning, and so many other areas. And this helps us quite a lot. At the same time, we've also started to understand better about what data scientist means. The role of data scientists has been even more and more important over the last few years. And the primary objective of a data scientist is to derive actionable intelligence from high volumes of data, essentially big data. So let's get into data science. What is data science? If you read this paper, you would find a really nice quotation where they say data scientist means a professional who uses scientific methods to liberate and create meaning from raw data. Two things are important here: access to data and using scientific methods. It's not just creating queries and visualizing the data, but it is also about the scientific process that's involved in data science. Data science involves knowledge and understanding of different fields, a lot of different fields like applied mathematics, statistics, scientific practices, data engineering and manipulation, data science innovation. There is quite a bit of programming as well, understanding analysis across product life cycles and so on. There are lots of different aspects. Now, if you go to this website by the UK government, there is a clear definition of what they imagine a data science skills to be. Now, in order to understand the field of data science and the idea of big data better, let's look at something called Gartner's hype cycle. Now, Gartner is a global research and advisory firm, as you are, I'm sure you know. They periodically review how emerging technologies are being adopted, and they map it to different cycles. So over here, it's important to note how these cycles behave. So let's assume a new innovation has come in. When they come in, there is a period of increased expectations. So this is where people feel that this is the new thing. This is going to be solving all of the world's problems. And at some point, that gets saturated, and we come to a peak. And this is what they call it as peak of inflated expectations. And then once that peak is over, it goes down, and people understand that the expectations were overhyped. And it comes to a point where it is kind of like a lowest point of disillusionment, and that's what they call as trough of disillusionment. And then slowly, as people start picking up this technology, this new innovation, make it more applicable to different contexts, to different products, to different businesses, that's when it slowly starts to be more productive, more operational, and then eventually comes to a plateau of productivity. That's where the technology reaches its height, reaches its possible height. So looking at big data, this is something that started coming up at around in 2011, 2012. Big data seemed to be at that stage where it was getting to this peak where people expected too much from big data. Looking at it afterwards, over the period of next few years, we saw big data following through this peak. And then it came through to this trough of disillusionment. So we can see big data being something as initially very hyped, everyone talks about it, and then slowly coming down to a point where people are starting to make use of it, operationalizing it. So how does it look now? Looking at a very recent hype cycle, we see big data actually doesn't show up in this cycle. This is from 2020, and it's quite strange to see that big data doesn't even show up. Instead, what we see are things which have started picking up, which started from big data, which has aspects of big data, we see a massive increase of interest on artificial intelligence and lots of different things like explainable AI, things like augmented development, responsible AI. These are starting to become more prominent. We also see things like graph technologies becoming very prominent. So that's quite interesting. We don't see big data as much as we would have thought, but we see things around big data, topics around big data. So Gartner's hype cycles provides a good indication of where we are heading. Our experience and observations also highlight several of these trends. Now, it's important to know that big data doesn't appear, but that doesn't mean that big data is a solved problem. It's not a solved problem, but a considerable amount of effort has helped solve some of these challenges. But new problems have started to emerge, and that's why we see new things, new trends around artificial intelligence coming up. So what do we mean by these trends, and what kind of trends are coming up? Let's say the first thing that I think would be useful for us to talk about over here is more power. We always need more power to process information. So we see a lot more resources being put into more power, but we see an interesting trend here. Edge processing, in-memory mobile processing is coming up. Apple's new chip, M1 chip, is now capable of doing a lot of really complex machine learning software. It's able to deal with large number of machine learning tasks. And that's quite interesting because the more we see progress in there, the more we see machine learning, artificial intelligence being embedded within devices. Imagine artificial intelligence embedded within mobiles, where without the need to contact cloud services, collecting data on mobiles, processing them, doing real-time alerts, and so on. Edge processing is becoming very relevant with Internet of Things and sensors as well. So we don't see sensors anymore as devices which are just collecting data. We see them processing and reacting to that as well. Another trend that we see more in terms of natural language processing is not just the need for processing data or text and capturing entities or named individuals from text, but rather trying to capture relationships. So nowadays we see things like Google Knowledge Graph or Facebook Graph. An example of this is where you search for a particular topic on Google and you see this context window on the side. And this is not just that topic, but it's also related topics, provides additional information about the dimensions of this particular building or dimensions of a particular city or so on. So you get contextual information further using these kind of graphs. We see another interesting challenge coming up, and that's from social contexts. Understanding social context has become even more and more relevant. We have seen what Cambridge Analytica happened, what kind of implications we had on privacy, security, ethics. So we are seeing a lot more effort in this area. We also see quite a lot of effort in bias and transparency, and that leads towards explainable AI. We do a search or image search for doctors, and we see that the responses are highly biased towards one particular demographics. And we see a lot more interest in data science applications for social, cultural problems as well. So data science has started to be an interface between data scientists and business, government, executives, and so on. So we are observing data science being applied for non-data scientists, where non-experts, non-technology people are using more and more of data science. And this is being enabled through plugins, modules, libraries, and so on. And we can foresee data scientists being not computer scientists, but maybe domain experts or people who have understanding of a particular problem, taking on more and more roles around data science. So that leads us to the question of what does a data science process look like within organizations? So let's start with this problem where a data scientist typically looks at a vast set of data. They then write queries, write scripts, generate reports, process this data, and that is provided as findings to senior management, stakeholders or clients, and so on. But in addition to that, they need to understand better what senior management want, what users want. So they need to collect requirements, they need to understand business and social contexts, they need to conduct experiments and explain their findings, redesign experiments, and so on. So there is a lot of tasks that a data scientist needs to be doing. That means a data scientist has a lot of responsibilities. And this is something that has started to become more and more unscalable. So what we see now is the emergence of a new type of data scientist, and that's what we call as type 2 data scientists. And they end up being the interface or the bridge between senior management, stakeholders, and the data scientists. So what does the type 2 data scientist mean? So if you go to this link down at the bottom, you'll see the type 2 data scientist is a data savvy manager. They are typically responsible on understanding the business context, understanding domain knowledge, understanding how the business responds to data, and so on. They have to tell the story of what does the data say. And they typically are the people who are managing data science teams. And this is quite important because this is a gap that was existing in the data science area for a long time. And there is a severe need for type 2 data scientists. They will not only understand business aspects or social contexts, but they will also have a very good understanding of the technical contexts. So all of these things that type 1 data scientists know or they work with in day-to-day business are things that data scientists, type 2 data scientists, need to know. So that leads us to the information school and what we are doing in Sheffield Information School. So this is a brief introduction to who we are. The Information School was founded in 1963 as Postgraduate School of Librarianship, and we do interdisciplinary research on chemoinformatics, information retrieval, health informatics, and a lot of different domains. Currently, we are 33 academics and over 60 research staff and PhD students. We are quite proud that we are the second in the world and first in Europe for library and information management. Now, the MSc in data science is a 1-year full-time or 2 or 3 years part-time course. It is accredited by the Chartered Institute of Library and Information Professionals. And what we are trying to build are type 2 data scientists. So we are not just building programmers, we are not just building people who only understand aspects of data science, but we are building professionals who are very well versed with all aspects of data science. We are targeting graduate students with good honors degree who have work experience, but it's not essential, but some knowledge of statistics or data analysis is required. English language competence is also required for this course. We have lots of different recruiters for data science graduates. Our graduates are in many organizations, as you can see below, but not just in one country, they are spread across multiple countries. Our course has several aspects, so we will start off with the basic aspect, which is working very closely with the data. So we have particular models on business understanding, data understanding, preparation, modeling, evaluation, deployment, and so on. And we also have understanding of business context, so there are modules which aim to understand businesses better. There are modules which also look at focusing on societal contexts. So these are the modules that are core modules, and these are modules that all students need to do. But we have elective modules as well, which are things that you choose from. So you have a range of options, and you choose from some of them. So I hope that was an interesting session on big data, data analysis, and data science. And if you have any questions, please feel free to get in touch. Look me up, you can send me an email, or you can also get in touch with our Twitter page or our Facebook page, or just send an email. So thank you for listening, and if you have any questions, please do feel free to ask. Hello, and welcome to this online.
Okay, well, that's the video. That's a pre-recorded session. I hope you found it useful. You found it interesting about the data science process, and we've discussed a bit about what happens within data science processes. And I've also shared some links which you can't take from the video, but hopefully I can reach out to IDP and share some more links as well. So if you have any questions, please feel free to ask, and I'll be happy to answer them. As you can probably imagine, I do not know much about the administrative aspects or the admissions aspect, but I'm a lecturer, so I know more about the data science course, data science modules, and I'm happy to answer questions on that. And also, I'm sure IDP will also have quite a lot of ideas about the administrative aspects as well. So please feel free to ask any questions if you have them.
Great. Thank you, Dr. Suvodeep, right, for the great presentation. Definitely we know a lot more about the data analytics and the challenges in which the industry and the wide-ranging impact that we are coming to foresee, right? We have no questions, right? Probably because your presentation is crystal clear, right? And definitely we hope that to hear more from Dr. Suvodeep in our upcoming fairs and events. Great. Okay, thank you, Dr. Suvodeep. Would you want to join in the virtual fair? Okay. Or would you be signing off at this point?
I think I will be